This video is about calculus and specifically rates of change. And in this video, I'm going to mostly focus on distance, speed, acceleration type rates of change questions. So here's our first example. The distance travelled by an object in meters is given by the formula s equals t cubed minus 2t squared plus 3t minus 4, and t is measured in seconds. And we want to find three things. First of all, the distance travelled after 2 seconds, the speed after 3 seconds, and the acceleration after 4 seconds. So now distance, speed, and acceleration are three different equations. And it's a good idea with this type of question to actually write those three things down before you begin. You're kind of providing yourself then with a menu of equations to choose from to do your calculations. Notice that although our formula here is called S, it's actually the formula for distance, and that happens quite frequently in this type of question. So just be aware of that. S tends to stand for distance. So distance is just that formula written down. Now I want to get the formula for speed. Well, speed is how distance changes over time. And so we can write that down as ds dt. And ds dt is simply the derivative of our distance formula. So we'll differentiate. We'll get 3t squared minus 4t plus 3. So now we've got distance and we've got speed. So just be clear there, speed is got by differentiating the distance formula. And now finally, I'd like to just have the acceleration formula to work with. So acceleration is how speed changes over time. So acceleration is my second derivative. So it's d squared s over dt squared. And to get that, I'm just going to differentiate speed. So then I get 6t minus 4. So we have our three formulae, and I'd just like to pause at this stage to point out that in some questions, they may ask you to find distance or speed or acceleration at any time. And when they say this, they don't mean pick a random value for time and stick it in. They mean just what is the formula for distance or speed or acceleration or whichever one it happens to be that they're asking about. So these are my formulae for distance, speed, and acceleration at any time. Okay, so now we'll go about answering the question. So part 1 says, find the distance travelled after 2 seconds. So if they're talking about distance, well then clearly it's the distance formula that I want to use. And if they're saying 2 seconds, that means that my time is 2. So I want to let t equals to 2, and I'm going to fit it into this distance formula here. As always, don't forget to show your work, and then make sure that there are brackets around what you're subbing in, and then just type it carefully into your calculator. And in this case, I get an answer of 2. Now, don't forget, as always, if there are units available in a question, make sure to use them. So distance, I know that the question is dealing with my measurements in meters. So my distance is going to be in meters. So just make sure to put that m at the end there of your solution. Okay, so part 2 of the question says, find speed after 3 seconds. So again, now this is why it's useful for me to have my three formulae written down. I just go and look for the correct formula. So speed, I'm going to be using this formula here, ds dt, and they're saying after 3 seconds. So in this case, time is going to be 3, and I'm going to substitute 3 into the speed formula. Just like that. And again, make sure you've got brackets around what you're subbing in, show all your work, off to the calculator, do your calculation. And in this case, my solution is 18. Now don't forget, it's speed that I'm talking about, and my units are meters and seconds, so my speed is going to be meters per second, which I can write as m/s. Part 3 of the question then asks me to find the acceleration at 4 seconds. So at this stage, you probably have the idea. Acceleration is what I want. I go to the acceleration formula. They're saying at 4 seconds, so I'll sub 4 in for t. So in this case, I'll get 6 times 4 minus 4, and I'll get 20. And again, because my units are meters and seconds, then my measurement for acceleration in this case is going to be meters per second squared, which I can write as m/s squared. So just to recap, I start off in the question with my formula, in this case for distance. I write down my three formulae, distance, speed, acceleration, and they provide me then with a menu of formulae to choose from. And then when answering my questions, I simply choose the correct formula and sub in the appropriate value for t. And remember that if the question says find distance, speed, or acceleration at any time, that means they're just looking for the formula. So here's my second example. An object is thrown upwards and its height from the ground in meters after t seconds is h equals 600t minus 5t squared. And I want to find out, first of all, after how many seconds is the object temporarily at rest? And secondly, find the greatest height the object reaches. Well, the first thing to point out is that the height something is above the ground is just its distance off the ground. So height and distance represent the same thing. So if you see height, or h is equal to, at the start of one of these formulae, don't let it put you off. It's the exact same as s in the previous example. Of course, when I find my derivatives, I'll call them dh dt and d squared h over dt squared. So again, it's a good plan in a question like this to make your list of your 3 formulae before you begin to do any calculation. So I'm starting by writing down height, which is just the formula I was given in the question. And then I'd like to find speed, which I get by differentiating once. And I'll call that dh dt. And in this case, it's 600 minus 10t. And then I'll find acceleration, which I get by differentiating a second time. And I can call that d squared h over dt squared. And in this case, that comes out as minus 10. Now, I may or may not need to use all of these formulae when answering my question, but it's a good plan to have the 3 of them written down in any case, so they're there if you need them. Okay, so let's go back now and have a look at the questions. So part 1, now this is phrased quite differently to example 1. Part 1 says, after how many seconds is the object temporarily at rest? So we need to stop and have a think for ourselves for a second, what's actually happening? Okay, something's been thrown up in the air, and it's going to travel up initially until it gets to its highest point, and then it's going to travel down again. Now, there was force put into it. It was given, a bit of energy to send it up into the air, and it was slowing down the whole time. And when it gets to the top of its trajectory, we can say it momentarily stops. And then it begins to accelerate back down towards the ground again. So when a question like this asks us about the object being temporarily at rest, it's talking about this moment at the top, where it pauses before it begins to fall back to earth. And the key calculation here is the fact that when it pauses, when it stops temporarily, it has a speed of 0. And so now I have a formula that I can use in part 1. If the object is temporarily at rest, its speed is 0. Here's my speed formula. dh dt is 600 minus 10t. And I will let this formula equal to 0. And then it's very simple to solve for t. I'll bring the minus 10t across. I'll divide 600 by 10. And I'll get a result of t equals to 6. And again, just don't forget, you want to use units. So they're asking me to figure out after how many seconds the object is temporarily at rest. So t, of course, represents seconds. So t is 6 seconds. The second part of the question then asks us to find the greatest height the object reaches. So if you look at our sketch of the trajectory of our object, you can see that this point at which it pauses, at which its speed is 0, is the top of its trajectory. That's its greatest height. And I now know from part 1 that that occurs at 6 seconds. So to find the greatest height, I can simply use my height formula and put 6 seconds into it for t. So there's my height formula. The greatest height occurs at t equals 6. So I substitute that into the formula, and I get an answer of 3,420. Now again, don't forget, I want to include my units here. And so since I'm talking about height, the distance is measured in meters. So I have to include that at the end of my solution for full marks. You might notice in this question the similarity to max and min questions. When they say find the greatest height, that's the same thing as saying find the max height. And if you think about max and min questions and how we deal with those, we normally get the first derivative and we let it equal to 0. So the first derivative in this case was our speed formula, which we let equal to 0, and we solved for t, and then we subbed it back in. And that's exactly the approach that we've taken in max and min questions as well. So just be aware of that as you're going through a question of this type. And finally, here's example 3, which is different from the previous 2 examples because it's not dealing with distance, speed, and acceleration. But sometimes you come across a question like this, so it's no harm to see how they work. So In this example, I'm told that the relationship between P and Q is given by P equals 2Q cubed plus Q. And I want to find the rate of change of P with respect to Q when Q equals 4. Now, the key phrase in this question is that we're looking for the rate of change. And whenever you see that phrase, rate of change, straight away, that's an indication that you're going to have to differentiate. So the rate of change is the derivative. Okay, so that means I'm going to take my formula P and I'm going to differentiate it. And of course, I'm going to call it dP dQ. Remember that when you're differentiating, the name that you give to your derivative will always be on top, P in this case, which is the name of the formula, and on the bottom, in this case Q, which is the variable that occurs in the formula. So in this case, I differentiate, and 2Q cubed, of course, don't forget the power comes down in front and multiplies, and then I take 1 away from the power. So I'll get 6Q squared. And then I have to differentiate Q as well. Now don't forget this Q that I have here at the end is the same as 1Q. So when I differentiate this, I end up with just that coefficient plus 1. So my derivative is dP dQ equals 6Q squared plus 1. So I have found the rate of change at any time for this formula, but now I specifically want to find the rate of change when Q equals 4. That's pretty easy to do. It just means sub in 4 for Q. So if Q equals to 4, dP dQ will be equal to 6 times 4 squared plus 1. And in this case, that's 97. And there's no units to worry about in this case because there are no units mentioned in the question.